Hello, I'm Amy Phung, and we'll be doing a video lesson on the intro to end behavior polynomials. Let me turn my laser pointer and let's get started. So the objective of this video lesson will be to teach viewers how to identify a polynomial's end behavior by its given graph or equation. Before we get into learning about the end behavior, we need to know what positive and negative infinity is, as well as understand where it is on the y and x-axis. So to start off, positive infinity are all positive values or values greater than 0. These numbers are 1, 2, 3, 4, and so on. And these numbers will go on to become infinitely positive as it continues on. And negative numbers, negative infinity, has the same concept. It's when negative numbers are infinitely negative as it continues from over here. Negative numbers are negative 1, negative 2, negative 3, and negative 4. I've labeled over here where on the y-axis the numbers either become infinitely positive or infinitely negative, and same goes for the x-axis where the numbers are infinitely positive and infinitely negative. So we need to get an understanding on what the definition of end behavior is. Simply put, the end behavior of a graph is describing what happens to the graph of f of x as x approaches either negative or positive infinity. This example right here is just to expose you to the type of material we'll be learning during this lesson. What's important is to notice that the polynomial equation f of x equals x squared plus 2. We need to notice that the leading coefficient is 1 and that the exponent is an even number 2. And we'll know why that's important later on in this lesson today. So what we need to know that's important is that the middle part of what's ever happening on the graph is not important on this lesson, as it doesn't make an impact on the end behavior or anything. All we need to focus on are the end parts of the graph. So let's focus on graphs with even exponents, and we'll learn why that's significant in this lesson. So when the leading coefficient is, so the graph can be different, the end behavior of the graph can be different based on the leading coefficient, also known as A, or its even or odd exponent. Well, in this section, we'll be specifically discussing even exponents, and we'll later be talking about odd exponents, but for now, we'll just focus on even exponents. So through this lesson, we'll learn that when A is greater than 0, with an even exponent, both the left and right of the graph will rise, while when A is less than 0, the left and right side will fall. So let's go into when A is greater than 0. So when there's a positive leading coefficient, the left and right side of the graph will rise, and it will have the end behavior right here. F of x approaches positive infinity as x approaches negative infinity, and f of x approaches positive infinity as x approaches positive infinity as well. So we have an example right here. X to the fourth minus 3x cubed plus 3x, and we can notice that the leading coefficient is greater than 0, and the exponent is an even number. So on the left side, we can follow the graph, and we notice that y is going to positive infinity as x is going to negative infinity, as written over here. Fx approaches positive infinity as x approaches negative infinity over here. And now on the right side, f of x approaches positive infinity. As you can see, keeps on increasing and continuing upwards as x also approaches positive infinity. X will just keep on getting larger and larger as this graph goes on. And it can be written out as said over here, as fx approaches positive infinity as x approaches positive infinity. And to reiterate what we learned in the previous slide, we can see that the end behavior is the same as the leading coefficient is 1 and the exponent is even. It will have this same end behavior. F of x will approach positive infinity as x approaches negative infinity, and f of x approaches positive infinity as x also approaches positive infinity. So how do you determine the end behavior of a graph when you don't have the physical picture of a graph in front of you to look at? Well, now that we've went over those two previous slides and examples, we know that when the a value is greater than 0 and the exponent is even, it will have this end behavior. f of x approaches positive infinity as x approaches negative infinity, and f of x approaches positive infinity as x approaches positive infinity as well. And we also know that both the left and right side of the graph will rise on both sides, so we have a kind of mental image of what it looks like, and we can also know that the end behavior is the same as all graphs with a greater than 0 and an even exponent have that same end behavior. Well, is the end behavior different when a is less than 0? Well, yes it is. When a is less than 0, both the left and right side of the graph will fall, and it has the end behavior right here. F of x approaches negative infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. So we should look at an example of the graph. F of x equals negative x to the fourth minus 3x cubed minus 1. So as we follow this line over here on the left side of the graph, we notice that f of x is continuing down to negative infinity as x is also going down to negative infinity. And it's written out right here, f of x approaches negative infinity as x approaches negative infinity as well. Now let's take a look at the right side. F of x approaches negative infinity. You can see that right here, y is approaching negative infinity as x is approaching positive infinity. Yeah, this is where positive infinity is on the x-axis, and this is where negative infinity. This is the exact end behavior of the graph. And if we look at this graph, the first thing we can notice is that the end parts are exactly the same. They're both facing downwards. Although the middle part isn't the same, that is not important in this lesson, as said before. Okay, so this is a graph of f of x equals negative x squared minus 3. And we can see that the y value is infinitely decreasing, which means it's going to infinitely negative values. And so is the x value. It's going to negative infinity as well, as this graph will continue on. So it can be represented by f of x approaches negative infinity as x approaches negative infinity. And over here on the right side, we can see that y is again going to negative infinity, but this time x is leading towards positive infinity. And it's written out right here. F of x approaches negative infinity, while x approaches positive infinity. As we can see, it's just going to keep on going down, down, but x will just keep on increasing and leading to infinitely positive values. Now that we know that, when we look at polynomial equations, if we see that a is less than 0 and x, the leading exponent is even, then we know that it has this end behavior. As we see over here, it says y equals negative 2, which is less than 0, and x to the x squared, which is even exponent, plus 3x plus 3. We know that this shows that it has the end behavior of f of x approaches negative infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. And we also know that the graph will have both the left and right side falling. So what happens when the exponent is odd, not even? So right here we have two equations showing when a is positive and when a is negative. Well, what we know that's different from the previous slides, we notice that the exponent is now odd. Well, when the exponent is odd, it's a bit different. When a is greater than 0, the graph will fall on the left and will rise on the right. When a is less than 0 with an odd exponent, the graph will rise to the left and fall on the right. Let's get into more detail about what happens when a is greater than 0. So when there's a positive leading coefficient, or when a is greater than 0, it will have this end behavior. F of x approaches negative infinity as x approaches negative infinity, and f of x approaches positive infinity as x approaches positive infinity. So here's the example. F of x equals x to the 7th minus 2x, and we can follow the graph on the left side, and we can see that y is leading down to negative infinity as x is also leading down to negative infinity, as right now right here, f of x approaches negative infinity as x approaches negative infinity. Now on the right side, we see that y is going up to positive infinity, infinitely increasing to positive values, and same goes for the x value. It's approaching positive infinity, and we wrote that out right here as f of x approaches positive infinity as x approaches positive infinity. And here's just one more example so we can see if this pattern is apparent in all graphs that have a greater than 0 and an odd exponent. So if you look on the left side, we see that yes, f of x is approaching negative infinity as x is approaching negative infinity, and the same goes for the right side. F of x is approaching positive infinity as x is approaching positive infinity as well. So we see that these two end behaviors are exactly the same. So what can we conclude? That polynomials that have a greater than 0 and an odd exponent will have this exact end behavior, and its graph will also fall on the left and rise on the right for all of them. So this polynomial example right here that I have is y equals 5x to the fifth plus 2x plus 3. And we can first see that a is greater than 0 and the exponent is odd. So we know for sure that it has this end behavior, and we can already see, like, we can visualize the graph without needing to know what's happening in the middle. We already know that the left side will be falling down and leads to negative infinity. The y will be leaning to negative infinity, as said right here. As the x also leads to negative infinity, and on the right side of the graph, we know the right side will be rising, which means that f of x will be going upwards to positive infinity, and x will also be going upwards to positive infinity. So how about when a is less than 0? So when there is a negative leading coefficient, it will have this end behavior as follows, and the left side will be rising as the right side is falling. So the end behavior will be f of x approaches positive infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. Well, let's look at some graphs so we can actually understand what this end behavior means right here. So here is an example. So f of x equals negative x cubed plus 1. So let's look at the left side of the graph. So we see that y is going towards positive infinity as x is approaching negative infinity. As it's written out right here, we can see that yes, f of x is approaching positive infinity as x is approaching negative infinity as well, as stated right here. And then now let's look and see if this part is true for the right side as too. So we see that f of x is going downwards to negative infinity, which is yes, f of x is approaching negative infinity, and x is approaching positive infinity as this graph is going to continue on. So yes, f of x approaches negative infinity as x approaches positive infinity. Right here, this end behavior is true, and it has the exact same end behavior as the graph that we will mention now. So as f of x approaches positive infinity, it is, x will approach negative infinity. That is true for the left side of the graph. Now let's see if this is true for the right side as well. Yes, the graph is approaching negative infinity on f of x, and x is also approaching positive infinity. And as I said before, it is exactly the same. The end behavior right here is exactly the same, as well as the ends of the graph is the same as the previous graph we just looked at. So now we know that when a is less than 0 with an odd exponent, it has this exact end behavior, and the graph will be rising on the left side and falling on the right side. So if we look at this polynomial equation, it says y equals negative 3x to the fifth plus 5x plus 7. So we can first identify that yes, a is less than 0 and the exponent is 5 odd, as I said before. So we do know that its end behavior of f of x approaches positive infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. Well, that's it for this lesson. Thank you for watching. And if you need clarification on any parts, just rewatch, rewind as much